Hello and welcome to this video on differentiation. Today we'll be specifically looking at the product rule of differentiation. The product rule is often stated as follows. If you have two functions, f and let's say g, these are both functions of a variable x. Let's say you take their product, so you have f times g, and you want to find the derivative of this product. As you may have seen, this is a formula and it's equal to the derivative of g times f plus g times the derivative of f with respect to x. This is a very common formula, as you may have seen it many times. Today I'm going to attempt to prove this formula. So first of all, we have the two functions, f, a function of x, times g, which is also a function of x, and we want to take its derivative. So we want to differentiate it with respect to x, and we want to find a formula for this. So we are going to use a very clever trick here, and we are going to rewrite this product as follows. So here we have the derivative with respect to x, and this product we are going to write it as in terms of the exponential function. So we have e, which is the constant, approximately equal to 2.71, and we are going to write this product as follows. So what I have done here is basically I have taken this product and written it in terms of the exponential function. So how have I done this exactly is as follows. If you have two numbers or two functions, or basically any function or a number, this can equivalently be written as the follows. And why is this true? Because the exponential function and the logarithmic function, so here I am using the natural log, are inverses of each other. So basically it's like adding 10 and subtracting 10 from the number will give you the number. In fact, the natural log is defined to be the inverse of the exponential function. And so this is an identity always. So because this is true, I'm going to rewrite this function, the product of these functions actually, as the exponential function raised to the natural log of the product. So I haven't done much, I've just rewritten this in a more fancy way, because this is a very clever way of writing it. Since we know that the derivative of the exponential function is in fact just the exponential function. And the derivative of the exponential function raised to another function, so let me say k of x is a function. So basically if I have e to the power k of x, where k of x is some function, this is equal to, using the chain rule, e to the k of x multiplied by the derivative of the function k of x. So using this formula, I'm now going to rewrite this step. So this is a very simple formula. Basically the exponential raised to any function k of x is just the same thing, exponential raised to k of x multiplied by the derivative of k of x. So this is just the chain rule of differentiation. Okay, so now I'm going to continue using the previous fact. I can rewrite this as the derivative of the natural log of f into g, since this would be the function k of x in this example, and this whole thing multiplied by simply the original function that we began with. Now, this function, if you remember, is just another way, as you can see here, of writing the product of these two functions. So what I'm going to do is now I can simplify this and write this as f multiplied by g. So this is this function, they are both the same. And here, this derivative, I'm going to write it again. But, okay, so let me just erase this. But I'm going to make a slight change. As you know, the property of the logarithmic function, I can write the natural log of the product of two terms as the sum. So this is equal to natural log of f plus the natural log of g. And this is just the property of the logarithm. Now, since differentiation can be moved inside because we are adding two terms, this is f times g multiplied by the derivative of the natural log of f plus the derivative of the natural log of g, where f and g are the two functions we began with. They are both functions of the variable x. Now, keep in mind this last step. I will clear the board and come back. Okay, so I have written the last step which we have derived right on top now, and we are going to continue. So I'm just going to write down this product f times g again, and now what we have is the derivative of the natural log of f. So a quick aside here, as you may have seen, the derivative of the natural log of x is equal to 1 upon x. So this is a very easy to remember formula, but we need to make a slight change here. So we'll incorporate the chain rule. Since we have f of x, which is a function of x, we first write down the derivative of the natural log, which is just 1 upon f of x. And now we use the chain rule. So we take the derivative of f of x. And so the derivative of the natural log of a function is just 1 upon that function times the derivative of the function inside. So using this fact, I can rewrite the derivative of the natural log of f as 1 over f times the derivative of f, and the same thing applies to the second term. So I can rewrite it as 1 upon g, because here we have g instead of f, times the derivative of g with respect to x. Okay. And now we are almost done. We just multiply these two terms. So we take this term inside. So this gives us f times g of x multiplied by 1 upon f times the derivative of f, and times we multiplied by the second term. So this gives us 1 upon g times the derivative of g. And now all we have to do is simplify the terms. So we have 1 upon f and f. So here we just have g times the derivative of f with respect to x. And here the g's cancel, and we have f times the derivative of g with respect to x, of course. And so finally, this is exactly what we were looking for. So now we have proved that if you have two functions, f and g, functions of f, of course, and you want to find the derivative with respect to x, this is equal to, okay, so since this is addition, I can rearrange the terms as follows. Okay, so these two are the same, and so this is what we have proved altogether. And what this means is that if you have two functions, say f and g, and you differentiate them with respect to x, this is equal to the first function times the derivative of the second with respect to x, plus the second function times the derivative of the first with respect to x. So this formula is very nice to remember and simple. So it's just the derivative of the second multiplied by the first, and the derivative of the first multiplied by the second. So this is how we obtain the product rule for differentiation. And now let's look at a couple of examples. Okay, so here we have the first example which I'm going to give is quite simple, and next we'll see a little more challenging example. So now that we have derived the formula for the product rule, we are going to look at this example. So here we want to find the derivative with respect to x of this function, that is x cubed times sine of x. So this is, let's say, our first function, and this is the second. And so, as we have seen, the derivative of the product of these two functions will be equal to the first function multiplied by the derivative of the second function plus the second function, which is sine of x, multiplied by the derivative of the first function. So here I can just rewrite x cubed. Now the derivative of sine x with respect to x is just cosine x, so that's cos x. Here, since sine, I can just write it down as follows. And the derivative of x cubed with respect to x is just 3 times x squared. So what we have totally is x cubed times cos of x plus 3 times x squared times sine of x. So this was quite a simple example. As you can see, the derivative of the product of these two is this expression right here. Now we look at a little more challenging example. Okay, so for our second example, we have a slightly more challenging function. We have the natural log of x multiplied by the cos square of x, and we want to find its derivative. So the derivative of this whole expression. So again, we apply our formula. The derivative of the product of two functions is the first function. So we write down the first function multiplied by the derivative of the second function plus our second function multiplied by the derivative of the first function. So I write down here the natural log of x. Now the derivative of cos square of x, we can find it using the chain rule. So basically, if I just calculate it separately here, using the chain rule, we would have, this would be equal to, so this would be 2 times cos x multiplied by the derivative of cos x, which is minus sin x. So that would be equal to minus 2 cos x sin x. Okay, so I can write down this expression here, minus 2 cos x times sin x. So that is this first part, plus I can write down cos square x and multiplied by the derivative of the natural log of x. The derivative of the natural log will just be, as I mentioned earlier, 1 upon x. So totally what we have here is the natural log of x. Okay, so minus 2 times the natural log of x multiplied by cos x multiplied by sin x plus cos square x upon x. So basically the derivative of this function, the natural log of x multiplied by cos square x, is this rather lengthy expression. But it's key to remember how we interpret the formula. The derivative of the product of two functions with respect to x is equal to first function times the derivative of the second function with respect to x added to the second function times the derivative of the first function. So this is the formula that you have to remember, and solving sums will become easy. So if you understood this video, do leave a like. If you have any queries about any of the steps we have followed here, do mention it in the comment section. And do not forget to share this video and subscribe to my channel for more content on mathematics.